What's that? Yeah. Well, we'll engage after this, and that's another thing. Is like I mentioned kind of subtly that I'm just kind of digging into GraphQL myself and going further. So I'd love to put it out there as like if you guys get excited about it, get interested about it, let's connect outside of this. We've got a stack of business cards that I'm trying to get rid of. I got like 500 of these, so there's more where that came from. So let's get connected. LinkedIn, my meetup, something, and talk about what we can do with this, and try and keep everything plugged in. All right, so it seems like it's working. So we'll just hope. The prerequisite sort of easily Googleable questions, things you can find online, but this is kind of through my lens or how I look at things. So first of all, what is GraphQL? Like I said, a lot of you people already know, but in the context of this talk, right, APIs are going to more typically REST or SOAP or CQRS or something like that, which is typically based on one of those protocols. GraphQL is basically Facebook's approach to turning the whole paradigm on its head and thinking, okay, what if we could, radically change how we do things and make it a little bit easier to rapidly develop? And this is what they came up with. And the thing that makes it really cool is it's a great simple interface and it gives you a lot of flexibility. So let's get into some of those benefits in detail. Before we go on, this is kind of what it looks like. There's a little bit more stuff that goes on. It's served over HTTP or HTTPS or WebSockets, whatever you're using as your transport layer. But it's a text-based protocol where you can do queries, you can do mutations, things that change data, and it's really about what you're trying to do, what data you want. So in this case, you can kind of infer what's going on here. So we're doing a query, so we're trying to retrieve data. We're not necessarily changing server state. This is like a GET request almost. And we're going to do a query called list events. So maybe for something like meetup.com, we're trying to get events from the database. And we're looking at ID, name, start time, and end time. So that's basically us saying on the client side what parameters we want to be served back or what properties we want to get back. So that's kind of a first look at GraphQL. For those of you that have seen it, like big whoop, no woo for you. For those of you who haven't seen it before, that might look really weird. So welcome. And let's talk about why you should want to mess with all that weird syntax. Because it is weird. It's very different from what you'd be doing like JSON and REST. So there's three key things that kind of stick out to me. There's a lot more benefits, and if you Google like why GraphQL or GraphQL benefits, you'll find some really long blog posts and stuff. But really, simplicity is the key one. You don't have to remember any URLs. There's just one URL. It's server/GraphQL or server/API. That was cool. It kind of cut off the mic. So it's kind of less cognitive load. You're really just using almost, it's similar to CQRS in the sense that it's like a remote function call, like list, to go back to that example, list events. It's almost like you're calling a function on the server and getting a result. So cognitively, it's I think a little more natural to some of us, definitely is to me. Extensibility is kind of a big one. So if you decide you're working on a front-end component and you want another property that you didn't realize you needed before, you don't have to ask a back-end developer to go and update that for you, or you don't have to jump over to the back-end and start making changes. You just put that in your list. So you could have like a description, just add it right there, and we start getting that data back if it's part of the model. So it's really extensible, and it's really flexible. You're not really thinking too much ahead of time of like how you're going to structure stuff. Now, obviously, that's always a good idea, but it does sort of free you up, and that's a common pattern with some of these Facebook productions. And finally, optimization. This one is actually really huge. Typically with like a REST API, if you're wanting to do like graph sort of queries, and that's kind of where the name comes in, is like you got a friends list, and your friends have friends, and so you want to get the friends of the friends. Describing that with REST is kind of tricky. It's like include friends, and then like depth equals, how far do you want to go or something like that. So it's a little contentious. For GraphQL, it's a lot more straightforward. But also like optimization from the client layer, you can send multiple requests for different types of data or overlapping data all in one sort of request. So there's some really cool diagrams. I probably should have included some as I was frantically throwing this slide together an hour ago. that basically show with HTTP, your client application is sending a whole bunch of different requests, or with REST, to the server. One to get your friends list, one to get your new messages, one to get whatever the posts from that day were. And on the GraphQL side, those all get sent in one payload and get returned and then parsed out together. So it's really this kind of polymorphic server endpoint. Again, kind of extending on the idea of turning REST on its head. And sort of the traditional protocols. And there's other things that can be done as well. The last little tidbit there is if you've got two separate components that need different types of data, they don't have to send two requests for that. And you don't even have to think about how to combine those requests. How to combine those requests together on your client side. You just write the request from the client components. Again, I don't know if a lot of you are front-end developers, but for me this is huge. It's like you can develop a component in complete isolation and think about what data it needs, and then move on to another component. And your cache layer, which is where all this data siphons through, that's the thing that worries about mixing and matching the data. I'll kind of show you a little bit about how that looks like maybe near the end. But suffice to say, it's really optimized in terms of network requests and some other the cool wins there. Finally, I think GraphQL is awesome. If you disagree, I'd love to talk to you afterwards, especially if I managed to get through this whole thing and you still don't like it. I'd love to hear why. But it's really looking at a problem, and this is, I'm not a huge Facebook fan, but I love React and I love GraphQL, so maybe I am. It's a way of, they took and said, let's look at a solved problem like REST and APIs, and let's try and resolve it in a very different way. And so that's what it is. And so at the very least, it's interesting to look at and try and think about and kind of wrap your mind around new paradigms. And that's kind of a really cool thing that we all get to do in this industry. And then some sort of nods to some other things that kind of are wins there. Oh, cool. I'm that good. Thank you. Appreciate it. Yeah. If you hear some big snickering or questions, feel free to call people out too. It's a fun party game. Or So there's a couple little things here like schemas. One huge area of contention, of course, is type systems and all that. And I don't like type systems because I'm a JavaScript guy. I know, I'm sorry. But the area where I do find a lot of gaps beyond small, subtle bugs around spelling and capitalization is between sort of service boundaries. So you've got your client, it's expecting a certain surface area from the server, like what is the schema the server serving up? And then you've got your server sending, a particular thing. Now, in type languages, there's ways to sort of share these things, but you have to be using something compatible. With GraphQL, it is sort of a schema system in which you're defining your schema on the server, and you could reuse that schema on the client, or you could reuse a subset of that on the client, and they're basically speaking the same sort of colloquial language. So it's not a huge thing, but it can make your code a little less error-prone, especially across that service boundary. And then, of course, versioning. I read this somewhere, and I don't fully agree. I am kind of skeptical. They say versioning isn't really a thing anymore because you can just add and remove and change things. It's like, technically, it's very easy to create a GraphQL API that you can break clients by changing something innocuous. So versioning is always going to be a problem in computer science and engineering. But it is different, and it is a different paradigm. So some of the issues there are solved. And finally, flexibility. We're going to look at how to write a server from scratch in JavaScript, again, my lingua franca. But you can wrap anything in GraphQL, including existing best servers, and there's some cool tutorials on the web about how to do that. So it's a nice way to say, like, let's not touch our existing infrastructure, but let's make something available for clients that we can rapidly iterate, and then maybe look at kind of working backwards from there. And that's a lot of words. So here's where it starts to get interesting, hopefully. We're going to ask how to get started. So if you're familiar with Node.js and React, like the demo is going to be like a couple of seconds, although I'm not going to go real heavy on the React stuff, so we'll look at that kind of near the end, and if you're interested, I've got some more examples for you later. But you can use Express with a GraphQL middleware. If you're not familiar, Express is a really popular REST-oriented library for Node, and you can pull in just a middleware off the shelf and start using it, and you can have something really fast. And then there's a really cool UI to play around with it. So let's get into that. I didn't actually get the demo music, so just imagine something in your head, I suppose. So I'm going to try to do this from scratch real quick, and it might crash and burn, which is fine because I do have the exact implementation I'm going for prepared. So I'm just going to call this live demo. I'm going to go over here and open it in my favorite editor, VS Code. Let's see. Close folder, open the folder. It all feels very sort of zen, you know. Close the folder, open the folder. It's pretty much what I spend all of my days doing. All right, so we'll start with this live demo, and I'm just going to run through like the basic stuff, but I'll try to narrate as I go. I'm pretty bad at talking and worse at talking and typing at the same time, so we'll start a new project. We'll just skip through all that. We'll install the dependencies, so we'll do Express GraphQL. That's the middleware I talked about. Maybe I should have gotten a chair. I'm going to grab one and just go through here, just to make it a little less awkward. Although it's still pretty awkward, isn't it? Oh, that's great. Should have gotten a tie. Express GraphQL, and there's one called GraphQL Tools, which lets you kind of render the schema, and you'll see what that looks like in a second. Cool. So we'll get those dependencies in there. Fortunately, NPM has gotten a lot faster from its old days. And then we can do this all in one file. So I'll just do that. Basically, we're going to require a bunch of dependencies. So Express is that REST/HTTP. It's really a HTTP framework, but people use it to make RESTful stuff. So I'm going to require Express. I'm going to require Express GraphQL HTTP. You can call it really whatever you want, but Express GraphQL. And then I'm going to require something from GraphQL Tools. Okay, and that is make executable schema. So that's the thing that kind of builds your schema. And the schema, there's two ways to do it. There's a text-based way where you just kind of write out the schema, sort of like you would do with SQL if you were writing raw SQL, which is probably a bad idea. And then there's like an object-based way where you can write it in sort of native JavaScript or native Java or whatever your language of choice is. I'm going to use the text-based way just because it's easier to read and a little more straightforward. But there are options. You're not alone. If I could just get this a little bit further away from my mouth, that'd be great. All right. So first thing is we're going to make the server. We're going to use our GraphQL. Did I spell that right? GraphQL HTTP. Yeah, we're going to use that. It's a function that we pass an object into, and this is our configuration. So this takes two things. GraphIQL, which is something you can turn on. That's that live editor that you get for free, which is really one of the things I'm most excited about. And then, of course, your schema. So we're going to write that schema right now. So you write your type definitions and what kind of queries your API supports. And you can break these apart, or you can just write them in one giant string if you're kind of daring like I am. Not that daring. So we can do our first type. So let's do an event. And we're going to give that an ID, and it's going to have an ID type. And so that's one of the cool things about this is like you're kind of, it's schema based. So you're defining what types you support in your type system or your type defs here. So we'll give it an ID, we'll give it a name, that'll be a string, and we'll give it a description. If I misspell something, just call it out because I do that a lot. And start time, and we'll make that a string. We'll store it as ISO format, I guess. Although there are some really cool extensions that support sort of different types like date, time, and stuff like that. And finally, we'll define our queries. Type query. And so basically, you have sort of a root namespace, and you can add types to it like event. And then query is a special type that you define sort of these kind of like functions. So list events. And this could take parameters like this, or it could not take parameters. We'll skip that for now. And then in that case, we just need to do this. So we can tell it we're going to return a list of events. We could have it return just one event, but then we should probably name it properly, like get one event. So we'll call it list events, and we'll have it return an event. So that's half the battle right there, is getting the type system set up, and you can kind of experiment with these. And then the next thing is your resolvers. And this tells GraphQL how to get your data. So we'll use a query type, because that's what we've defined in our schema. And we have to provide a resolver for each of our queries and each of our mutations. We'll get into mutations in a second, hopefully. And this is the part where I have to cheat, because this gives you something like root, params, something else, and AST. I think this is like context or something. I'm not 100% sure. This is sort of where I'm still learning, or still memorizing anyway. And then we can return something. So let's just have all of our stuff in memory right now, and we can look at potentially how to use databases and storage like that. And the cool thing is you can use whatever you can access. Thank you. You can use whatever you can access from your code. So any type of backend you want to use, it's totally agnostic to that. It's just about having a way to interact with it. And there's some tweaks you can do to make it more performant on the backend. I might hint at some of those in a minute. So we'll do ID equals 1, name equals APIs and IPAs, description, cool event, and start time. And this is another area where I have to cheat. I'm just going to pretend this is an ISO date. Evening, late evening. I have all this written out, so we can look at that one and compare to how I did under Big Ben. So now we have at least one event we can serve, and I'll, as sort of a shameless plug, I'll add my event as well. So that's Seattle JS Hackers, and evening. Oh, this should be late evening. So our event isn't actually as long as this one. Cool. So that's pretty much what we need, and then we can just return the events here. One really cool thing is, and I imagine it behaves similarly in other languages, you can return promises here, so you can do asynchronous activities in your resolver, and it just handles that transparently. It's not a big deal, but it's really nice to have, especially when you're prototyping. Cool. So then we'll do schema, and we'll this is where we build our schema essentially, and we'll do type defs and resolvers. And that is all we need to try this out. Cool, so now we can run our server. Of course it's going to crash. It's important to import your base libraries there, so things that sort of central to your whole talk, you want to bring those in as well. Never mind. npm install. Cool. So we'll include that really important dependency as well, and now we'll run the server. And it's not going to give us a response because we didn't really log anything, but we can do that. There we go. Oops. It swallowed my. It's trying to be so helpful there. This is one thing about technology is like if it's trying to be helpful, sometimes it's like anti-helpful. Don't try to over-help the user. Okay, cool. So we listen. Close. Shoot. I'm just following this. All right, so we'll jump back into that project. Hopefully, recent live demo. It's going great. Don't worry about it. All right. All right. Cool. So we're listening on the root. Usually you put it under some kind of namespace, some kind of path. So we'll just do this GraphQL, sort of a tradition for the demo. Cool. So we'll start that again. We'll come in here and we'll run it there. All right. So this is that really fancy. I'm sorry that took so long to get here. This is that really fancy API kind of explorer that I told you about. So you can see all the types you defined, including the special query type and all the methods. And so you can really explore, it's like free documentation right there. So that's pretty sweet. And then we can query that in sort of, is that readable? All right. So we can start typing. So we'll do a list, and then it tells us events. So we go there, and then we hit Control Enter, and it'll give us a default selection, and then we can start to add to it. So we'll add the name, and we'll start getting that. Start time, end time, and that's pretty much how it works. So your client can basically specify what it needs. If it doesn't need the ID, totally fine. I think that's a bad idea, but you could do it. Or you could just not include the times, maybe in a list sort of thing, and then have that on a detail page. So it's really sort of functional. And the cool thing is you can do multiple queries in one sort of request. So you just name it something. And you can do the same query. You can do separate queries. And then they come, well, not like that. List events conflict. These events are true. Fields. I had this working the other day. Promise. There we go. So you can do, you namespace sort of your query, and so you can send two queries over in one request. And if we look at the network, we can see that, oh my goodness. Okay. We can see that it's sending both of those back, and we can see what we sent out to get there, which is in here. So do the parse. So you can see our query, and it gets sent over as text, and those can be combined into one. So we do two requests with one request, which is really sweet, and it's even better when they can kind of overlap. So that's the basics. Let's look at changing data. So you can do the same thing. We'll define a mutation. And this is any time you want to change some data. So we can have one for add event. And to do a mutation, you need an input type, which specifies what you're expecting to receive as part of that. So we'll say new event or event input. And then here we're going to require all of these things, and we'll optionally take an ID so we can reuse the input. I'm not 100% sure that's a great idea, but we can require a string here. We probably want to require a name for all of our schema. So you can add the bang to make a field required. And then we'll make the other ones optional. And then this one becomes event and event input. So it's kind of similar to a lot of type systems out there. And then you can define what it returns. So we'll just have this return the new event that we created. And then we'll define a mutation resolver for that. So we'll do add event, and that's going to take in a lot of these same properties, although we're not going to have to use all of them. And for those of you that don't know JavaScript, I apologize if you're completely lost, but if you have questions, I know I'm kind of buried. Absolutely. So a lot of the sort of way that can be done is sort of in your model layers. So if you have a database, you can enforce the constraints there. You can force it in software. I actually haven't looked into defining it in GraphQL limits, or like I haven't looked into that. I think that would be sort of an optional thing, and the tutorials that I've looked at, it hasn't been highlighted. But typically, you've got a business layer or a storage layer that's enforcing a lot of those constraints, and this is really sort of a simplified approach for that. So the types are pretty simple. You've got a float, a string, Boolean, that sort of thing, and not too much more. And then the requirements that I've seen are like that. So you can definitely add some extensions on there to enforce that, but I haven't come across that. That's a good point. That's a good point. Yeah, let's chat about that afterwards. I'd love to look at that more, because part of the documentation that you get, you'd want to know exactly what those are. Yeah. I mean, so I would say it's really useful anywhere where you're rapidly iterating. So in a lot of senses, sure, maybe you'll develop a schema and you won't make too many changes there, but there's always sort of new things being rolled out that require access to data, and it's really nice in those scenarios if you don't have to make any back-end changes. You can just pull out additional things that aren't needed. So it's great for greenfield, obviously, because you can sort of rapidly iterate and you can change things, and there's not a lot of changes that have to be done on the server side. But I think even in the existing sort of implementations, it can be an asset there. So we can get into some more like use cases and stuff, but as somebody who does like a lot of mobile apps, I think it's a compelling use case there. Like combine it with React Native or whatever, and all the components sort of live in isolation. You see this really big shift from like service layers, like you've got your UI layer that consumes your service layer that consumes your your backend API that consumes your database, to really sort of vertical slices, so where you've got your component thinking about all the data it needs and totally ignorant or kind of separated from any other component. I'll show you a little bit of that on the React side, and maybe that'll paint that picture a little bit better. Okay, let's finish the mutation real quick, and then we'll move on with the whole presentation. So here in the add event, this params is going to be everything that's passed in here. So I'm going to have an event property that I want to pull out of that. And so I can do something with that. So I will say if this event, and this is a side product of how I'm choosing to code this. Maybe we could say save event. So I could make this somewhat polymorphic and have it handle new events as well as existing ones. It's probably dangerous. You probably want separate ones. But for this example, I'll combine them just so you can see what that might look like. So we'll do save event. And if the event has an ID, then we know we're trying to update. And if it doesn't have an ID, we know we're trying to add it. So here's the simplest way I can think to do that. Events, we'll find the existing event that has that ID. And then we'll copy all the properties out of the one that we were passed into the existing one. So and we can throw errors here too, and it'll just show up as an error in the request. So if we don't have an existing event, we couldn't find one with that ID, we'll throw a new error. That's kind of a good behavior to do. So then we'll loop over here. We'll say event, existing event. We'll copy this key over, so this property. So it could be name, it could be description, that sort of thing. And then we'll return the existing event. And then if it doesn't already exist, we'll just add it to the list. So that's a little bit easier. And like I said, this might not. In fact, I'm confident this is not a best practice because this is not how we'd normally code. I promise. But it's a nice sort of way to show like you're not really constrained to think in like a CRUD sort of model here. I mean, you could do that with Rust, but people might get upset. Cool. And oh yeah, we have to generate an ID. So we'll say event.id equals events.length. Cool. All right, so now we can run this, and we can do that mutation. The mutation is a lot like a query. Oh, we need to refresh so we can grab the latest schema. You can see mutation appeared here, and we can see a save event. It takes an event input. We can see what fields that requires. Again, that sort of free documentation is pretty compelling. Probably not. Yeah, thank you. Yeah, that would have been fun to debug, so thanks. I'm going to change it back. We'll debug it. Pretend you saw nothing. So we can save, we'll do save event, and we can pass in an event here. And the syntax is somewhat like you would expect. We'll do name, rad event, we'll do description, coolest by far. And then we'll ask for the ID back, we'll ask for the name back, and the description. And we'll ask for start time and end time and see what we get for that. Cool. So we just saved our first event, and it got saved with ID equals 2, which should not have happened. So yeah, that was an error in my code. We're going to add 1 to that. And try again. So that one will go away because we're only running in memory, which again is another bad idea. There we go. So we got a 3. And the ID field is sort of a special type here, which GraphQL uses to sort of identify a record. So it does a lot of things around caching, and so that ID is important for it to be able to say, is this the same thing? So that should be globally unique, or at least unique within the context of the type. But you know, global unique identifiers are a pretty good idea in sort of big distributed systems anyway. Yeah. It doesn't really enforce a constraint. It looks like it comes through as a string. So it's really, because it's sort of a special type, it's not going to coerce there. So to make this still work out, I'll be, let's see. Yeah, I'll just be really lackadaisical here. Again, bad coding practices, but you'll forgive me, I hope. Cool, so we'll make that rad event, and then we'll query for it and see what we get. Cool, and then we can get the name and more stuff from there. The other thing we can do, this is the last thing I'll show you in this demo, and then we'll just kind of move on because I'm sure this is getting kind of old, is we can add some parameters to our queries. So for list events, I'm sure it's nice to get all the events, but you probably want to add some parameters. So we'll do name just for now. So that'll take a string. And so that name will be available here in our params over here. So we'll say, we'll just pull that out of here, and we'll say, okay, if we got a name, we'll return events dot filter. So we'll do a search in that events list, and we'll do e.name matches our name. And to be really lazy here, we'll do a regex, which is, I guess it's regex, to do a case-insensitive match. So we don't have to worry about that. This is also bad to take unsanitized input and turn it into regex. I know that. Sorry for showing you this way. It's bad, I know, but forgive me again. So we'll take that and then basically, if name was defined as part of the input, it'll filter on that. And if it's not, it'll just give us the whole list. So you can add like paging properties and stuff to it as well. Cool. So we restarted our server, I think, so we lost that other one. But now we can add a name here. So let's do API, and we can do an empty string. So it's kind of a simple way to pass in some parameters. You can make some of those required if you want. I haven't really explored if there's a way to sort of make them conditionally required. It's like you have to have at least one of these, but not all of them. But you can just throw that on there, and then it'll bark at you if you don't provide it, which is kind of cool. Expected name, found nothing. See, name is required but not provided. So it's kind of nice. There's a lot more you can do with it in terms of customization. Obviously only able to scratch the surface and go with what I know, but hopefully that kind of gives you an idea of what it's like writing an API, and we only did that in just a few minutes. And it all fits on one page of legal paper. I guess it would be a little bit long, depending on your font size. But sort of a basic implementation is really straightforward, and then you can think of like how you can go on from there. So there's no questions at this point, though I won't assume that. Does anybody want to? Would you want as a consumer of that? Well, I would love to have GraphQL. That would be awesome. But I think there's probably a lot of tooling. This is another area where I just have a giant gap in my knowledge. But I'm expecting there's a lot of tooling to produce many different formats of documentation. I mean, one of the challenges here is like you're also querying against a live API. So, you know, if there's authentication and stuff, that becomes a little bit more challenging. But yeah, I would want to know basically everything that this shows me right here. So what queries can I do? What mutations can I do? And what subscriptions can I subscribe to? So that'd definitely be ideal. And then some of the things that he kind of hinted at earlier is like what sort of schema restrictions you have. And that's something I have to look into how to enforce at the GraphQL layer. So there's definitely a lot of value in having that up front versus once you get to the database.
Are there any full queries that are supported natively in the language?
It's really sort of I would say transport. I don't know how to. It's a query language, so it's just giving you an interface for interacting with your backend.
Can you like filter on that query?
Not from the GraphQL, as far as I know. It's really you're just sort of formatting the requested data for your backend, which I think makes sense ultimately because you're going to get more performant sort of querying from your backend. So like filtering is going to be faster and easier on the database side versus bringing all that data to your server. So ultimately, that's going to help. But in some cases, say you're wrapping an existing API, then yeah, you'd probably have to do that in your service layer. So that's sort of an incentive to say, like, does this provide us business value to build an app and run with it? And then if it does, then of course you start to re-implement that back-end service layer. Cool. Anything else before we? Yep. Oh, we got so many. You in the front first, and then we'll go back there. Although he beat you, sorry. Yeah. So I can make a gist. Let's make a gist of this right now. Why not? It should be authenticated, so I should just be able to drop it in. My GitHub is easy to find. It's Joshua. Actually, you know what? Yeah, that's fine. Let's do this. It'll be more real. And this isn't going to run directly because you're going to have to pull in these dependencies, obviously. Cool. Create public gist. All right. So you should just be able to find this through my GitHub profile. It's HutJ, last name plus my first initial. And then there's some other interesting ones there that you might ask me about as well. Where was it going? Okay, another question in the back.
Yeah, are there any like what would be the public APIs support GraphQL?
I have no idea. I'm really looking at it as sort of a thing for internal usage, but there's nothing that says you can't use it for a public API. I'm just such a self-centered developer that I'm really only thinking about my own projects. Yeah, that's definitely something I should have Googled before tonight. Does GitHub have a GraphQL API? That's a great one. I love this. This is thank you guys for filling in for me. Cool. Anything else before we continue? I'm probably running low on time. How am I doing? Yeah? Okay. Cool. So, like, yes, done. All right. 1 second. So we'll just jump through this. So, last things I wanted to cover before the end, but we can kind of save this for another talk. Databases, authentication, access control, all these things. So come find me afterwards. We'll kind of chat about this if you're interested. It's actually kind of nice. You don't have to subject you more to this. And then I've got an additional demo I'm working on for Seattle.js hackers, so we can look at that as well. But I guess that is time. So thank you very much. If there's more questions and stuff, I'll sort of handle them at a break. Yeah.
So I'm a very curious person. There's a folder called Friendship on the desktop.
That was going to be my example of like, because there's another cool thing you can do is graph like queries. So if you want to meet your friend, I can't tell you this, but you can do.
So we have a raffle. Does anyone have any more last minute raffle tickets? Can you show your